second. Yeah, I gotta post your videos in. Yeah. And just not. Okay, never mind. Stuff to say. All right, yeah, you can start.
Okay, thanks.
Yeah.
So for everyone being here, welcome to this workshop of Matlab. So here I'm. This is the first time for me to give an online workshop, so it's kind of challenging. But we will try our best to make use of this new way of teaching, and hopefully it can be beneficial for your coding. Sorry. Okay. So before everything starts, I just want to quickly introduce some basic settings about this workshop. So this workshop is really about introductory of Matlab. So we're going to start from the very basic of coding and teach you how to code step by step. Therefore, every beginner can follow every step. And the second is the student who enrolled in this 275, maybe it's a different code now. Anyway, so if you enrolled in this class, then you need to attend all on this workshop because we need to grade you. And also your grade will be depends on the quiz at the end of this workshop. And the third is this time we won't have signature form because we will make use of Zoom. But another thing I want to try is that since all the in previous class, when I gave some task for students to code, I would just go around the class to say how everyone code and to help them if they don't find a good solution. But this time, since I cannot go around, so I will encourage you when I give you some task to code, if you have some trouble, you could volunteer to share your screen. I'm not sure whether it's allowed. Maybe some of you, if you want to try now, could you help try to share your screen? Just anyone could share the screen. So therefore I can see whether you would be able to bring the screen out from me and share your screen to.
When I go to share screen, it says host disabled attendee screen sharing.
Okay. Hey, Eloy, are you there?
Yeah, let me see what I can do, okay? Give me 1 second.
Could you tell me where I can allow?
I'm on it right now. I gotta go to the
thank you.
website. Yeah.
So the basic goal of this is really to help you to solve your problem when you code, right? Because sometimes when I teach you how to code, you find it's easy, but when you really do yourself, you will easily get stuck. So the goal here is to help you. So I will highly encourage you to volunteer to share your screen if you found this trouble when you code. So so each task I will then just ask if there is some volunteer. If you want to just share the screen, just feel free to share it. And then I can directly look at your screen to look how you code.
Can you hear me?
I'm working on that. Give me 1 second. I'm working on it.
When I check share screen, I get a message. It says host disabled attendee screen sharing.
Stan, I'm working on that right now. Give me 1 second. So I'm trying to make it so that
on the lower row, there's a sort of a carrot looking and icon. And if you click on that carrot thing, it gives you options for screen sharing for attendees.
Thanks, Stan, for help. Thanks for your feedback. Is it good now? Could you try again, Stan?
Yeah, thanks, Dan.
Okay. Let's see, share screen. It still says host disabled. When you go into that caret, you probably have to go to advanced options.
Okay, could I try to stop share my screen and then could try again, Stan?
Let me see if I can do that.
Okay, so let me try. Host disabled, attendee screen sharing. I think when you go to that caret, you have to go to advanced options. And in the advanced options, it tells you whether other people can share.
Okay. Eloy, could you help on this?
Yeah, I just took away the privilege. So I'm trying to do that right now.
Mm-hmm.
So I just want to make sure.
Okay. While Eloy is busy with this, we can go ahead. And
Okay.
the last thing is let us know when you're done.
Okay, so if you go to share, what he said right there, there's going to be a little arrow on next to between chat and share. I think I put it where people can share now. So if I wanted to share, let's see if I can share my collaboratory.
It looks like it works.
Oh, that's great.
All right, so that means that everybody else can share their stuff.
Okay.
All right, let me get out of that. Stop sharing.
Stan, could you try again?
Can you share your stuff? I got something. Yeah. So now everybody in the
Great.
class can share their screen.
Okay, thanks. So
Okay.
I just want every task at least one of the student can share the screen, so we can really get into the cases of debugging the code. I hope that will help you guys know how do you manage debugging. Okay, let me go back to the slide. And before this ready teaching, I will have a very quick quiz on you just to test how much you already know about Matlab. And so it's gonna be very easy, and this will not be recorded. It's just free to give any answer you have. Let me see. Could you now go to the link I sent to you yesterday in the email? There is a link for the quiz. If you didn't go to this is the link you will see when you open it. Right. If you see this, then you just type your email address and take a few minutes to do this. Don't worry if you find it's hard. The goal of this quiz is just to let me know how much you already know about the Matlab, and also just to give you an impression of what will happen in this workshop. Just take 2 or 3 minutes to finish it. If you have any problem, you can message, you can in the chat room just message to me. You have problem, open the link. Yes, I think you can go to the link. So in the chat room, someone give a link, and let me try that link, whether that link works. I think it works. You can directly go to the link. So what you see in the share screen right now is my screen, and I will briefly go through this quiz. So there is only 6 questions as a very introductory about the Matlab. So first one is, do we need to align each line of code in Matlab? And the answer is no. And the second question is, do we need to align each line of code in Python? The answer is yes. So these 2 questions is actually one, because this is to tell, if you know Python, you probably know that when you code, after you type each line of the code, you will need to align those codes in a certain manner. Right? But in Matlab, we don't need to do this. So in Matlab, it's a more relaxed coding environment. And the third question is, what is the starting index of array in Matlab? And the answer is 1. And this question is also to clarify the difference between Python, because in Python, the starting index is 0. So in Matlab, you need to remember every array start from the index 1. And the fourth question is, what is A equal to this guy? So in Matlab, when you say a comma, it tells that the element was put in a row. And when you say a semicolon, it means that the element switch into a second row. Right? So here it means that we have type 3 element in a row, and then switch the row. So it can be a 2 times 3 matrix. And with this bit bracket, it means an array or matrix. And the next question is, which one is correct to define A as a 3 times 2 matrix with all the elements to be 0? So this one is 0's 3 times 2 is 3 times 2. And this 0 is a function. And if we give the 0 this arguments 3, 2, it tells that it's a 3 times 2 dimensional matrix. And the last one is, how do we define A as a 3 times 2 dimensional cell? And cell is also a function. If we want to define cell, just type cell and use this small bracket 3 times 2 to give us 3 times 2 dimensional cell. And every time when we use some function like zeros, like cell, when we input the argument, we need to use small bracket, right? So small bracket. And pay attention to that, the dimension should match, right? 3 times 2 rather than 2 times 3. So I hope this 6th question gives you a very quick sense on the style of coding Matlab. And don't worry if you now don't really understand how we choose these answers. We will introduce more in the later course and then submit. Okay. I think I should be correct. Okay, cool. And let's go back to the course to start introducing Matlab. Oh, by the way, so two things I need to mention. One is my internet sometimes this doesn't just happen to lose. So if I suddenly get offline, just wait me for 1 or 2 minutes. And the second is these 6 questions we just have will be the same as the final quiz for you. So the final quiz will have 10 questions, and 6 of them will be exactly the same way as we just have. So if you really can manage those 6 questions, you can really pass this course. Okay, so let's get back to the introduction of this software. So Matlab has several properties for us to code. First of all, this software has a very graphic interface and easy for us to interact it with. And the second is it has very relaxed development environment. As we have just said, it does not require to align each code, align the line of the code. And third is it is very good at numeric manipulation, such as matrix product. So it's very important to understand how the matrix product was conducted, which was learned in our linear algebra. We will review this when we get there. And the next thing is it has very friendly plotting functions. Therefore, you can visualize your data. And then it has many good documentations. So if you want to find some function, want to realize certain functions, you can just Google. And the last thing is it can be interfaced with many other languages, as Python and R. Sometimes we just, in the Python, we write some code and then we can call the scripts right in Matlab. So these several platforms can be interfaced with each other. So just an outline for this course. Day one, we're going to look at the software, right, to see how we can play with this software, and then we are going to learn more about command window and start to type in variables, define variables, and do some arithmetic operations, and then logic operations. And then we're going to write some scripts, some simple scripts to run it and see whether the script works. And after that, we'll introduce if-else statement and the for loops, which are basic, commonly used sentences in Matlab. And then day two will introduce more about the while loops and break statement. And after that, we go back to more, bit more complex data structure like vectors, high dimension matrix, and how to sort matrix, and how to define a even more complex data structure as cell. And then we will start to write some functions. So basically functions is another version of scripts, but we would just write it up, and then you can call these functions for different uses. And we read in some file and output files. And day three will be a bit more relaxing. We will do some plot, and I will tell some real examples of how we use Matlab to code. Okay, is there any questions before I go? If you have any question, you can unmute. All right, so let's start from Matlab. Could you open the software Matlab if you have? And when you open it, what do you typically say? This interface is something like this. Maybe different version has different interface, but it basically has these parts. So first of all, it has here there is a window. Right? So this window can be useful if you want to search some function, right? Because it has installed some many known functions here, and if you want to find out how to use these functions, you can just search them here. And the second thing is here in the left, typically in the left. This is the current folder. So it will show, if you see this loop here, so this is the path of your folder. So here, my path is in the disk C and in several folders. In this folder, I have those files in my folder. And the current folder is very important because every time you want to run some script, you need to make sure that the script is in this current folder. Right? So if you do not have the script in this current folder, it will output some error message, right, to say that there is no such script in the current folder. Or if you want to load some data here, but you do not have this data file in this current folder, then it will tell you we don't have file under the folder. So make sure that every file you read and every script you want to load was put in the current folder. And the second thing is on the right, there is a workspace. So workspace is the data that loaded in Matlab. So when we later want to deal with some data, for example, do some arithmetic operations, we need those data in this workspace. And otherwise, we cannot do operations on them. But currently, you see here, there is nothing in the workspace. So no data here, and we can't do anything about this because there's no variables. And then in the middle panel, there is an editor. So this editor is basically open mailing scripts. As you can see, I have many scripts here, and you can click on the bottom, on the top, and it will switch to different scripts if you have, and then you can edit the scripts. After editing the scripts, if you want to run, you can just click the run, right? You go to the editor here and click the run. You will run the current script. And in the bottom, we will have a command window. So command window is a window that you can directly type in something, and after type, you can run it. So it's like a short version of script. You just write a few codes. If the code is very short, they can directly write in here. For example, A plus B, and then it will give you some answer, right? Script is just a composition of lot of commands in this command window, right? So first of all, we will start to write simple code in this command window, and then later when we write a lot of codes, we will put in the script. Okay, so now we start from command window. So if you have Matlab open, you can click into the command window and trying to type the things I show here. For example, 2 plus 2. Right? And this one, 3, is upper triangle, 2, which is 3 to the power of 2. And you can type sign, and pi means pi. Right? So the Matlab has some short notation for commonly used mathematical terms. Pi is one of them. And if you have done this, could you type ANS and see what it will give to you? Let me switch to Matlab to show you how do we do this. Okay. Does everyone see my screen? If you didn't see my screen on the Matlab, you can just unmute and tell me. Okay, let's try some code. Great, thank you. Let's try some code. 2 plus 2. You'll give it 2. You will give it 4. And one thing you can notice that we have a variable started to be setting here, right? This variable, by default, it will name it as ANS. And ANS has a value 4. So next time, if we type ANS, it will just output this value for the variable of ANS. Right? So if you don't name the variable, it will by default to save as ANS. If I do another thing, for example, 3 to the power of 2, then ANS will be covered, right? Because by default it was saved in ANS. So now ANS becomes 9. So if you want to name the variable, you can give it a name, A equal to 2 plus 2, let's say. Then we'll have another variable called A here, right? You see A equal to 2 plus 2, which is 4. So you can define variables and do some easy mathematical operations here. And just remember that if you do not give the name, the default name is AS. And you can try a bit weird things. For example, 7 over 0. You can try it and see what it gives to you. And you can try those with a bit more operations with bracket, right? Just type it. This will help you get familiar with it. For this too, you will get the answer is INF. INF means infinity, because 7 over 0 is just an infinite number. So that's this. And if you type 1e plus 04, so 1e plus a number, it is a notation for the scientific number, right? So 1e is simply equal to 10 to the power of something. 1e plus 04 is 10 to the power of 4 times 10 to the power of 6, which will give you 10 to the power of 10, which is 1e 10. So this is just for you to know that there are scientific way of typing the numbers. And we can do many other operations, anything addition, subtraction, multiplication, division, exponential, and order. So order is just a small bracket. Remember, it's a small bracket, not big bracket, not big bracket. It's small bracket. Always small bracket to order the operations. And another thing is to be pay attention is semicolon in Matlab. Let's answer some questions in the chat room. Sorry, let me check that. I saw some questions, but I'm not sure whether I could answer all of them in time here. So one of the questions is, let's deal with these operations. So one question is to ask whether this one is the same as this operation. So we have two operations, right? So one is this guy, another is this one. So this two operation is the same because by default, the order of making these operations are multiplication and the divide goes before then and divide, the add and subtraction, right? So it's the same as in our what we learned from math class, right? So everything here you have a bracket for 6 times 2, but it's actually not necessary. So because it will automatically goes first, then the subtraction here. And the second question is, what does it mean for person? For this one, I'm not sure what this. The question is, what does it mean for unable to create a personal Matlab work folder? I think it's probably due to the your computer setting. Maybe the folder you are in is not allowed to create a folder. But I think typically, if you have the authority, you have the right to create the folders, I think it's okay. Let me create a folder here. For example, you can create a folder, right, by right-click in the current folder, and then it will give you a new folder. You can name it folder 1, and then it will give you a folder. Right? So if you cannot create a folder here, you can go to your folder window and create a folder and get into the path. Okay, let's go back. So as we have just mentioned that we need to pay attention to semicolon. Sorry, let me show what does that mean by we need to pay attention here. Before we have type. Oh, by the way, here, if you want to use some previous code, you have typing command window. You can simply type page up, right? Page up in your keyboard. Page up. It will make you search the previous code you have typed in the command window. You can search the page up, page down. You'll show that. Okay. We here previously we have a equal to 2 plus 2, right? And when we do it, it gives a equal to 4. And what if we add a semicolon here? If we add a semicolon here, the only difference is that it does not show what will be given to the A. Right? It doesn't show, but it will be saved into the workspace. So everything is the same. A will be give the value of 2 plus 2, except that with semicolon, it will not show in the command window. Right? So just make sure you remember this, because it will be useful later when we have a script. If you have A equal to 2 plus 2, if you have a semicolon here, then when I run this script, right, I run this script. The script is named as untitled, so it will run this script, and then it shows nothing, right? But it have give value to A to 2 plus 2. If I do not have the semicolon here, I run this script, it will show A equal to 4, right? Because no semicolon will show the result, right? So sometimes people want to show some result in the command window when they run a long script, and then they just need to do not have the semicolon here. And when the script goes there, it will show these variables and print it in the command window. So make sure you know that when to add semicolon. Most of the time we add, so therefore it does not show anything in the command window. If you want to print out something here, then you just need to delete the the semicolon. And another thing useful is called the comment symbol. So the comment symbol is the percentage symbol. And when you have percentage symbol in your command window, those words after the symbol will be commented. So it will not be excluded as a code. Right? For example, here we have cosine 2 pi and this comment symbol, cosine operator. And those guys will not be run as code, only in the previous. And will give you the answer to 1, and you can have many other comments. So the comments is just for you to tell the reader what is happening in the code. And let me introduce a bit more about the variables. As we have just said that in the workspace, you can have the values, the name of the variables and their values, right? X, Y, Z, we have A and S, have their different values. If you want to have those values in the workspace, you can try in your command window to type these codes. Please try it. Just get more familiar with the command window. After you have tried and check your workspace to see if you got those variables. I guess it's not very difficult. And another thing I want to mention is that Matlab also support to deal with the imaginary number. For example, I here, if you type I, so this I will be the imaginary number I. So if you type I in the command window, what will happen? Let's try I. So it will give the AS equal to this imaginary number, right? 0 plus 1I. And you can take the real part of this number as real I, which just take the real part. And what would be the answer? So it would be 0 because real part. And if you take imaginary time, it will be 1. Right? So give you the imaginary part of this number. Oh, sorry. Okay, so all these numbers, everything you learned in math class can be typed in the command window. And another important thing about variable is that Matlab is case sensitive, right? For example, if you try lowercase x and give it a value, or you can now, if you have the x variable in the workspace, you can have x here, right? X, because previously we have give it a value to be 9, and now you can directly call these variables. You can just call it, and then it will give you the value it saved as 9. But what will happen if you type uppercase X? Please try that. So the answer would be you do not have these variables defined, right? So this is what we mentioned before. Every time you want to call a variable, you need to make sure that they exist in the workspace. Otherwise, it will say it's undefined variables. And Matlab, sometimes it's can provide some suggestion to say, okay, maybe the variable exists is this lowercase because it's found in the workspace that has a similar variable, and then you give to be 9. Okay, so I also want go back to this AS. Let's try this command first in your command window. Could you type this first, and then I will introduce a tricky question about AS. Okay, first you type x equal to square 16, right? Then x will be equal to 4, right? If you type square 25, it will be automatically saved into a variable NS, right? As we previously mentioned, NS will be equal to 5. Right, so now you will see that in the workspace, x is 4, ANS is 5, right? So if you do not name the variable, it will be saved as ANS. Just make sure you remember this one, because later we will have a very tricky question about ANS. Okay, before getting that, I also want to introduce the a code called who. So who simply will give you all the variables that in the workspace you have. Right. You can simply type who in your command window. Right. You even don't need to type those guys, because you already have some variables in your workspace. Right. So then you will see all the variables in your workspace. They should be the same as what you have in the workspace. And you can also type whose, right? Try whose. So after you have whose, the result would be those detailed information of those variables, right? So, and then you know what's its size and what is memory, what is its type, and what's its value. So whose is just to read out all the things in the workspace. And we also need to, what if we want to delete some variables in the workspace, right? So code to do this is called clear. If you want to delete the variables, you can simply use clear and then space and these variables. You can try to use this to see what will happen. Let me try to, I just first check my workspace, right? I have A and S. What if I type clear A? Then there is no A, right? So A is deleted. And if I type whose, it will only give the remaining variable A and S. So a more quick way to clean everything in the workspace is simply to type clear. You can try that. Clear and type whose, then you will see nothing because nothing remains in the workspace. And clear is very popularly used because every time after you run a script, it will generate a lot of variables in the workspace, right? And then, but sometimes then you want to run a different script. When you run those different scripts, you want to make sure everything saved in the workspace before needs to be removed because they may have some double definition or use the same variables by using different ways in the different script, right? So you want to clear everything in the previous script and then run the next script. Right? So clear is very commonly used. So widely, a lot of scripts will have a clear in their beginning. A clear in the beginning like this, it's clear, semicolon. And therefore, when you run this script, it will clear everything in the workspace before it get into later codes. So clear is important because you might get wrong answer if you didn't clear and use the wrong value saved previously by some other operations you have done. So clear is clean the workspace, right? Remove every variables. And a related code is called close or, right? You can type close or and semicolon. So close or means to close the figures. And another related one is CLC. CLC is to clean comment window. We can try this view. A lot of things in the comment window, right? So it's kind of messy. And then I want to make it clean. Just type CLC. So therefore, I do not get distracted by this previous code. And then if I have a figure, let's say I type a figure, later we will start drawing here, just to give you a quick glimpse. If I type figure, so nothing was drawn, it's just a blank figure. And later we probably will have a code which will draw a lot of figures, and these figures will take up your memory. And so therefore you need to close these figures in time. So you will have close or, and then when you have this one, the figure was closed. So you simply have this close or in the command window, if you have a figure join in the script. After that, you close all the figures, make sure they do not take memory. Okay, I have a question. What is the difference between clear and COC? Clear is to clean this workspace. Clear. This workspace is gone. I have A equal to 1. I have A in the workspace, right? And then I want to remove this one. I simply type clear. It is no longer in the workspace. But COC is to clean everything in the command window. COC, everything in the command window was removed. Okay, right. So another student mentioned that you can use edit in the command window to run the script. That is correct. Okay, so now we have some basic things in the command window, and we, after some operations, you want to at some point you want to save the files, right? Because it's maybe it's a result, and then you can simply type save and give it a name, any name you want. Here is my file. You can give it any name. And then what it would do is it will save all the things in the workspace, all the things, into a file named as this guy. Right. And this file has the format of mat. So everything saved by default from Matlab is this mat file. So this mat file is a composition of a lot of variables in this workspace. X, Y, Z, A, and S will be saved. Could you try this? Save. And remember that this file will be saved in your current folder. And then after save, please close your Matlab and reopen it. It may take some time to close the Matlab and reopen. Just to see what will happen when you open next time. Let me save this file. When you save the file, make sure that there's no file with the same name, right? You can see in my current folder here, I have some of the mat file, those guys. And when you save file, just make sure you do not use the same name, because otherwise the file here will be covered. May cause some lose of your previous files. And make sure it's not the same name. So let's say I have a file new, a save. Then take a bit time to save the file here. So I will have those files. So what is in this file? So it's all the variables in the workspace. How can I say that? Let's say I clear the workspace, right? So nothing's in the workspace. Then even after you close and reopen it, then you can double click this file you have saved. So it will set load this file. You can even use this code to in the command window to load the file. But since you have interface, you can double click and it will load the variables into the workspace. So make sure that you save the files you generated to some place. Otherwise, your efforts might be wasted. And when you reopen it, as we have just said, if you, I did reopen, but if you try, you will see that it will be an empty workspace. And when you reopen it, you want to open the data you saved before, just double click it. Okay, I got some questions. Let me read that. So I'm not quite get the question, but let me try to address if I understand correctly. So basically, if you save, right, so if you save the file, so all the variables in the workspace will be saved. That's the only file you will be saved by having this saved. And public data we will introduce if you want to save specifically some variables. For example, if I have a B here, I have A, B in the workspace, but I just want to save A, only A. You can have a bit more complex code to do that. I'm not sure I can remember it. I must give it name, and I will tell what is the variable A. Let's try that. Oh, sorry, this one doesn't work. Sorry, I didn't remember it exactly, but the idea is you can save the variables. Okay, so now it works. So I only want to save one of the variables in the workspace. I can use this one. I give it the name of the file I want to save, new file, which is here now. And I only want to save the variables A. You can save other variables if you want. You can also add other variables. So you can choose other variables. You save any variables you want to have them in the workspace specifically. Right? If you do not specify them, it will save all the things in the workspace. It will not save anything in the command window. Command window is just some trial code you type for your own purpose. Anything in the command window will be not saved. Okay, since we get here, I have used this complex code of save, but probably we'll get back to this, how we use this, but here I think it's better to move on. We'll probably get back to this to see the bit more complex use of this code. Okay, so let's go back. When we reopen the Matlab, initially you have an empty space. Then if you want to load some files you previously had, you just need to double click, or you type in load this file in the command window. If you double click or you type load this file, .mat, everything saved will be reloaded into your workspace. Okay, let's have a quick break. Probably 5 minutes, and then we'll come back to a bit more complex things and get some water in 5 minutes. Okay, I hope you are still here. And we just had a few questions in the chat room. Forgive me if I don't answer all of them because sometimes it's just get crowded soon and I may not be able to answer all of them. But if you have any question, you can also just unmute and ask a question just to let me know and at least some of you are listening actively. So anyway, let's move on. So we just have talk about how do we deal with the comment window. And basically it's just input some variables, do some operation, and then save the variables in the folder. And then the next time when you reopen, you can load this file. Right? So that's what we have learned. And then the next, since we know comment window, we can work with a bit more complex structure, which is script. So if you want to have a script in the Matlab interface, you can click the new script on the left upper of your software, or you can type edit. Right. So if you type edit, you can try in this comment window, or you can specifically give it a name. Right. And as a result, you say that there is a file, script file, saved in the current folder. If you don't name it, it will probably be a file called Untitled, which will be not saved. You will need to run it and then it will save. If you give it a name, it will be saved as the name you give it, and then you will have a script file. Script file, the format is .m. So Matlab script file is all .m. So then everything you have in the comment window we previously type in, now you can type in directly in the script. Right? So here is one example. I have gene expression 1, 2, 3, and I add them and I have some divide, and then I will have a code called DISP. DISP is a short version of display. So Matlab, when you want to print out something in the comment window, you can have this DISP or display, and then small bracket and these variables. And then we run this script. If you type anything in the script, you can try it. And then you will display these variables in the comment window. Let me show you how we do this. Okay, first of all, I get here, I see it's messy in my comment window. I just want to clean it. So I type save. I have a script saved before, this script named Untitled. So the name actually doesn't matter right now. And then we have clear. Here, clear. You would just, if I run this, I click run, you would just clean everything in the workspace, right? And then I can have type any operations in the script. So these are simplest things that we can have. And then I can, if I want to show the result, I just simply type DISP and show this variable, right? So if I type display, say it's the same thing. And let me just remind you, we can have another way of doing this, just type C, right? Remember, if we do not have semicolon, it will show the things in the comment window. So what if we click the run? We see what's happening here. We will say we run this script called Untitled, and then you will display the variables 3, right? Display 3, and then displays again because we have a display here. And then since we have C here, you have C equal to 3. So we have 3 times displays these variables. So both this way are displayed in the variables. So the reason for us to display is you want to have a quick check on whether the result makes sense. And just run a script that you display the most important things you want to know about the result. And when you run this script, the script is exactly the same idea of typing the command window. So it will automatically save these variables in the workspace. And therefore you have everything in the workspace, and you can, after that, you can save them into your folder. So everything in the script which is defined in the script will be saved as a variables. So I also have mentioned here, display variable name is just to display the content of these variables. Okay, now could you open the script file I shared to you? So I previously sent a link, right? So to all the files of this course. It has 3 zip files which contain the scripts we will test for these 3 days. You can now unzip the day 1 script. And then it will generate a folder, right? The folder will have a bunch of scripts. Please get into that folder in the Matlab. Right? When you unzip, the scripts will be saved into a different folder. And now you need to get into that folder and such that the folder becomes the current folder. Just take a minute to do that. If you have any question, you can even share your screen. Oh, sorry. So yeah, so one of the students didn't get the file because when I sent this link, send all this material, some of the email address doesn't work. So the email was bumped back. Yes, when you unzip the day 1 student file, and you need to get into that folder in the Matlab, right? Could you try that? Right? Because this is like also practice. When you have a package of code, the first thing you need to do is to get into the folder path of this package, right? I can show you an example here, right? Let's say I have many folders here, and in your case, the folder should be day 1 student, right? And in my case, it's in day 1. I just get into this folder and then becomes a current folder. Right? So then you have all the script I have in the current folder. So ideally, you should have the example 1 to 13, probably, yeah, 1 to 13 in this current folder, right? And now you can open example 1. Double click example 1. And then you will have a script on your screen, right? So you first need to unzip the day 1 file, unzip. right? Because currently it's a zipped file. You need to unzip. Then it will generate a folder. Right. Once you have the folder, you need to remember where you put it in this folder, right? You need to remember where you put this unzipped file, and you can find them here in the list loop. I have all this is a commonly used path of my folders. If you don't find them, you can click here, right? And then it will pump into a window, and then you will need to locate the file, the folder you put into your computer, right? For example, I have here day 1 student, and I select it, and then get into the folder, right? So that's how you locate the folder you unzip. So after you do that, please open example 1. And there is a task for you. You need to do some manipulation for these variables. So this is an example of a gene called IRF. So IRF gene has a naive value, and it has a stimulative value.
I'm sorry for interrupting. I simply, I had downloaded the day 1 stuff, and but I don't have a clue sitting in Matlab how I'm supposed to get those files and put them into current folder.
Could you share your screen?
Okay.
Yeah, you can try that. Yeah, this is important. Yeah, because
share screen.
Let me try to see whether I can help you.
Okay, so here I have Matlab class.
Sorry, I didn't see your screen yet.
Oh, you don't.
Okay, cool.
I'm not sharing screen.
Yeah, I saw your screen, and I saw you have those folders.
Yeah, a folder I've called Matlab. One is day 1 student, and in day 1 student, here I've got all this good stuff.
Yeah.
So it's sitting in my computer.
And what you need to do is to load them in the Matlab. Right. Yes. Here you see.
That's what I don't understand how to do.
And could you use mouse to click could you go a bit up? Yeah, the open the folder. Yeah, you can tap open. You can click the open.
Open.
Open. Yes, open.
So Matlab, but you want me to go somewhere else here where this thing is stored. Is that right?
Yes, exactly. You need to go to the Matlab class.
Day 1 student, and here's all the stuff. Do I want to select them all and open?
Okay. Yeah, you can select one of them. You can select example 1, for example.
Example 1. Okay, so let me
and open it.
Okay, so open to Matlab class and day 1 student and example 1M. Is that the one you want?
Yeah. Could you open it?
Open it. Okay.
Could you run it?
Could I do what?
Run. Click the run on the upper. Right.
There's run.
Right.
But how does it know what to run?
Run.
Yes, but I don't see where this example 1 is amongst editor or command window or current folder or anything.
Did you click the run? Sorry, did you click the run?
Now I've clicked the run.
Does it pop something out?
It is not found in the folder because I never put it into the current folder.
Yeah, you select change folder.
Change folder. Okay.
Right. Now you get into that folder.
It's
Right.
So when I
I
open,
saw the problem. So I am not sure I encountered this problem myself because in your Mac, let's say, could you stop sharing? I can
okay.
go back to my sharing.
So let's see.
Okay.
How do I stop?
Yeah. I get back here.
Okay.
If in my computer, I open it, right? So I get into new folder. I can open the folder. Right? This is open.
How did you know when you open? How did you know where to go?
Oh, yeah. So sorry, I should do this way. So when you open the file, it just open the file, right? So it does not get into the current folder. It does not do anything in the current folder. What you need to do is to click this one. Select a new folder. This small button here. Right, small button, you get into folder, you select the folder, and then it will jump into that folder. Does it make sense? So another way we have tried is even if you open the Matlab file, right, in any other folders, in day one folders, I can run the file, it will pump into this one, and you just need to click change folder. Then it will change to the folder of this script. So there are two ways. One way is you set the path yourself. Another is you open a file in this folder and run this file. Is that clear?
Not a bit.
Yeah, so if you want simply set the folder, you just click this button. Right, browse for folder.
Here.
I guess you have a better in the
browse for folder.
Right.
So it's browse for folder. And there I happen to have found it by some magic. And here are some files. And it asks me to open. I have no idea what to do.
Then you just get into the folder and then click open. Does that work?
I get into the folder, I click open. Open, ta-da. And now I see in current folder, I see a bunch of example 1.m, 2.m, and so forth.
Yes.
Yes.
So that's where you should get it.
Okay, well, I see it's there. It's there. I'm not sure I could do it now if I needed to. But it sounds like the important thing is
you can click on the script, right? So we will go through these scripts one by one.
So I'm supposed to click on, for instance, example 1 now?
Right. Double click example 1.
Okay.
So you should be able to have a script here.
Yes, got it. Okay, I will mute now. Thank you.
Okay, so that's all. Yeah. So now you have a script here, right? So a task for you is to save the result for this operation, right? So save the result into the current folder you have. Right. You need to insert a line of code to do that. Right. Please, all of you, try this. While you are trying that, I saw a question in the chat room. Yes, you can also copy the path file, the path of the files into the path in Matlab to navigate. Yes, exactly. That suggestion is correct. So you just type one code to save the file. right? So here I already have the answer here. You can save anything you want. You can save the result as the name of my result, and you can click run. Sorry. I have since I've clear all the things in the workspace. There's nothing in the workspace, but I have saved my file into my result. Right. Let's search the folder. I should have my result math file, which saved all these variables. Right. If I double click the math file, I will have all the things being saved. Right. Then they will be reload in the workspace. All right. Okay. So then let's get to example 2.
Maybe I'm just really dense, but I have not a clue. I've made those changes to the file here, and then I don't know how to operate it. I don't know how to make it do what it's supposed to do.
You click run here.
Okay.
Click run.
And then presumably in the current folder, I have something called my result now.
Right.
Okay, sorry.
Okay, cool. Then could you open the example 2? The task for example 2 is to reload what you have just saved. Right. So you need to insert something here. Load the file you have just saved such that you have the variables in your workspace. Once you have them in the workspace, you can use them to do some operation, right? So the only thing to insert is to add the name of file you have just saved. Could you try that? Yes, it's better when we load the file, it's better to include the extension. Because if later when you deal with many files, they may be in different format. So you may load Excel file, you may load text file, you may load math file, right? In order to avoid the confusion, and then you need to specify the file format. So here I have saved my file as my result. So I can simply load this file, my result.mat, and I can quickly check that whether I have this file in the current folder. Yes, I have. Right? And then I can load them, and let's see what happened. I can run. So the code will run line by line. These are commented, nothing done here. Okay, here then it will load the file. And what's loaded is those RF values I previously have saved. And what it did in addition is it used these two variables, stimulated and naive, and do a subtraction to get RF induction, which is a new variable. And then after that, this new variable will be saved into Workspace. And notice that here we do not put a semicolon, so it will print out this value into the command window, right? So it will print out this value. Therefore, you see what's the result you got. Right, so in the chat room, yes, for the math file, you can delete this extension, right? But what I just meant is for safety, it's better to specify the format because, for example, for the Excel file, it may not work if you do not have those extension. So it's better to have this extension here. Okay, so this is the answer for this first two examples. Right? Just save the file and load the file. And after you load, you can do anything you want for the variables saved. And now could you open the example 3? And before do anything, you can just simply run it and say what it will give to you in the comment window. You see the result? Ideally, you should give you those kind of result. So why? Because first, x equal to pi, right? Pi is 3.1416. Right? So it will give, since we do not have semicolon, you will print out this x equal to pi. And this example is just to show you that we have different format of the data we can, to save different position we want to keep. For example, if you change the format to be long, so this line is a bit more precise way to record the number, right? Have many digits, many more digits afterwards. So if you change that, then you type x equal to pi, you have more digits. And if you change the format to be short, to be blank, to be round, right? So rad simply means ratio, so rational. So it's a rational number, fraction number. Right, so you can change the format any way you want to save the file, to save the variables. Right, and the task here is add a code line of here to set back to the default. Right, since you have this output here, right? You see the odd output, and could you add a line of code here to change the format of this number to the default? Take a minute to do that. So one question from chat is, what is back? Honestly, I do not know what is back, but simply see the result, it only keeps 2 digits. So I'm not fully understand all of this format, right? It's just here is just example to, I just random put some example of these formats to show that we can change them. Right? But back is simply a different way of, yeah, it only saves 2 digits. This is what back does. So there are even more of those formats. You can just Google them. So it's just a Matlab default way of naming the format. Right, so how do we set it by default? As we can see that the first one is the default, right? So you see here, x equal to, the first one, x equal to 3.1416 is the default. And which format agrees with this default? Right, so it's the second one, which is the short. So the default is short. We just need to set it to be short. Set it to be short and uncomment this one. And then the last one you get should be 3.1416. 1416. Right. So the default in Matlab is the short. And another question come from the chat room is, what if we want to save specific digits? What if we want to save the first 3 of these digits? I don't know whether there is a format to do that, but one thing I can do is to use a function called round x3. Let's see whether, okay. So round x3 is to take a value only up to the certain digits, right? I type x, so it would take the last 3 digits, keep only up to last 3 digits of x, right? By using the rule, if it's over than 5, it will be saved as 2. If it's less than 5, it will be negative, right? So by this way, you can specify how many number of digits you want to save, the precision of your number. So that's the format of the scope of this format is just to use some default format Matlab has. But when we, in practice, when we want to use them, the commonly used way is to use this round to keep exactly how many digits of number you want. Right, so this example is just to tell you that there are different formats. Just keep in mind that the default format is short and it only has 4 digits. Okay, let me quickly check the chat room. Okay, so if you mean the scope, once you have changed the format, it changes globally. Yes, that one answer from the chat room. Yes, once you change the format, everything in the Matlab afterwards will be kept using as that format unless you change it back. So numbers are 1 times 1 matrix. And then next we will go to work more with matrix. It's a bit more complex than number. And commonly use a function to check what's the dimension for this vector or matrix is called size. Size function, you type size, then you call this function, and then you give it argument, which is x here. It will return the size of this argument, which is 1 times 1 matrix. It is just a number, but it's 1 times 1 matrix also. Right? So you can now try to type the row vector at this way, and this, and then check the size of the row vector. This part will be a little bit confusing, so please type the row vector and see what you will get. Okay, let's, if you haven't finished, please keep going, because this is really important for you to remember how to define vector, right? You will get confused later. Let's say I name my row vector to be row, right? How do I define vector? If I just want to define number, I just simply type 1, right? For example, then it is a number. But I want to have a row vector. Then what I can do is I type the middle bracket. Remember, it's middle bracket. And then I insert the elements of the vector 1 by 1. right? So any elements you have, you may have any elements. Then you define the vector. Then you have these variables in the workspace, right? So this is a row vector. It has 5 elements. You can already say it's 1 times 5 matrix, right? But there are many different ways to define the vector. Let's say I can have, if I want to have 1, 2, 3, 4, 5, sorry, this vector, right? An alternative way to define this vector is to have 1 comma, column and 5, right? So this way, it will define the same as 1, 2, 3, 4, 5. It will give the same result here. And alternatively, we can have another way, is we have 2 comma here, and then insert 1. Right. So by this, we also have the same vector. Right. So let me explain what does mean by having the comma here. So comma means 1 to 5, 1 to 5, 1 from 1 to 5. And the default step length from 1 to 5 is 1. So here we just specify the step length by ourselves. 1 to 5 with step length 1. And the way to do that is to have the comma here. Right. So you can change the step length, let's say to be 0.5. And then it will give a vector 1, 1.5, 2, 2.5, up to 5. Right. So there are different ways to define a vector. You can insert element by element, or if you want to get lazy, you just insert it by using this comma 1 to 5, and then you can specify step length to have a vector. Right. So this one is very commonly used because, for example, if you want to draw a picture, you need to specify what is the x-axis and y-axis. Right? So x-axis, for example, 0 to 10, and then give it a step length. Step length is typically correspond to the resolution you want to have for your graph. Right? So this way to define vector is very widely used. And remember, it's comma here, comma and comma to specify step length in the middle. And another thing to remember is for this row vector, you even don't need to have the middle bracket. Right? With or without the middle bracket is equivalent. Right? You have the same thing, and it will give you the same result. Right? Without the middle bracket, it's the same. It's just having this middle bracket will help square out where is this vector defined. So now a task is, could you try to type this guy, 5, 1. 5, 1, and see what it will give to you. Anyone get a result? Okay, great. So I saw some of you say it's 0, it's an empty vector, right? And what's the reason? So the reason is that the default step length is 1, right? So if you do not give the step length by itself, its default is 1. And from 5 to 1 with step length 1, it is an empty vector. 5 plus 1 is 6. You will never go back to 1. Right? So it is empty vector. And the way to rescue this is you specify the step length to be -1. And then you will have a row vector from 5 to 1 with the step length -1. Right? So if you have a descending, you have a descending number here, you need to have the step length to be minus number such that it will give you a non-empty vector. I saw a lot of you get the correct answer. Thanks for your feedback. And now you can check the size of the vector by type size. If I type size, row vector, right? The size is 1 times 5. So it is a 1 row, 5 column vector. 1 times 5. And the size function has a bit more detailed use. You can specifically extract what is the row number and what is the column number. To have the row number, you just type size, this variable, and comma 1. So 1 is the row number. Right? And then 2 is the column number. So you can specifically take out the row number and the column number for vector or for matrix. And the reason for us to use this one is most of the time we want to scan the matrix row by row or column by column. Right? So then you need to specify whether you are scanning the row or it's scanning the column. Right? So size function can help you do that. And just remember that the arrays all start from at 0. It's different from Python. So this is another point that people might easily make mistakes. And once we have the matrix or vector, we can do the same operations to these vectors. So then all the things we learned from linear algebra will be used. So for example, you have 2 vectors, which are both 1 times 5. You can add them. Then its element was added. Okay. So it will give you the same 1 times 5 vector with every element to be 5. And what if you try this? You have the row vector, you have just typed, right? Could you please try to type another vector, but use the semicolon here, and then add this row vector and this column vector. Please try this one. Here, to define a column vector, remember now it's semicolon rather than comma. Comma is to keep in the same row, but the semicolon will switch into the next row. Right? This is a kind of reminder to our beginning quiz. If you use the semicolon here, it will switch to rows. Then at the end, it will give you a column vector. Right? If I do not have the semicolon here, it will show me it's a column vector. So then remember, you can see that the column vector, every element was separated by a semicolon, but row vector is separated by a comma. Right? So that's the key difference. And what happens if you add these two vectors, right? Row vector and, oh, sorry. Actually, I'll probably have some errors in my vector. I probably have set the default of Matlab to do this plus to be a different way of plus, but the it works for me. But if you could you try that? Yeah, probably this is due to the different version of Matlab. The previous version would simply say that it does not add up these two vector, right? Because its dimension does not agree. But if you have a latest version of Matlab, they may have improved this, to have this default to be a matrix. But I guess this one will not work. If I have another vector, let's see. Okay. Yeah, so I guess they have changed that. But if I do this, right. So if I have a matrix here, right? So here I have a vector 1, 2, 3, and then I switch the rows to be a different row. So therefore, I will have a 2 times 3 matrix. Now I add the matrix and vector, they will not be able to add up. I guess the previous adding up is the new Matlab has improved its power of calculation to enable such and. But in general, if the two dimension does not agree, then it will give you error. Right, so this is the, I don't expect that because maybe the you might have revised this. Right, so here now we get this matrix, right? So we have just mentioned that if you define the matrix, you have the same thing as vector, but every time you want to switch the row, you use same semicolon. Right, so 1, 2, 3, switch the row. The same thing here. Right. Once the two matrices have the same dimension, you can add them up. So this is what we learned from linear algebra. So could you type this matrix first, right? Because this also is to make you more familiar with the format of defining matrix. If you have this matrix, could you try this multiplication? The star is multiplication. And this is a tricky point we have here. So let me get into let me try to draw this. It's hard. Previously, I typically just write it on the board, but now it's just review the linear algebra. Right, because in my previous experience, about 80% of students after learning the class will still fail in this problem. And the reason for their fail is not they don't know how to code in Matlab, but is they don't know how to do linear algebra. Right? So I have two matrices, let's say A, B, C, D. Forgive my bad handwriting. Right, so if you want to multiply these two matrices, what is the matrix product tell you? Right? What is the matrix product? What is the result? Right. So the matrix product, the result will be A times A plus B times C, right? First row times the first column here. And the second is A times B plus lowercase b times D, right? So on and so forth, right? So this second element is AB multiplied by BD, right? So this is matrix product we learned in the linear algebra, right? But why it doesn't work out here? If you have really tried, you will show it doesn't work out, right? Why does it not work out? If you multiply this my matrix and my second matrix, which is these two matrices. Any answer to that? Why does it not able to give a matrix product? Right, so the problem is these two matrices does not have their dimension match. So if you multiply 2 times, here we multiply a 2 times 2 matrix, right? To multiply a 2 times 2 matrix, the dimension matches. But if we multiply a 2 times 2 matrix and a 2 times 3 matrix, right? Then it's not a valid operation because the dimension of this row does not match with the dimension of this column. This dimension of column does not match with the dimension of this row, right? So remember the linear algebra we learned in before. Right? So this is the case happening here. So this matrix has 3 columns, but the second matrix only has 2 rows. So it's not a valid operation. It does not give you any result. But Matlab has another operation called element-wise manipulation. Let me show you here. If we do an element-wise manipulation, which we put a dot here, dot multiply, different from the multiplication only, it will give you element-wise manipulation, where the first element is A plus A times A, second is B times B, third is C times C, so on and so forth. So these are 2 different manipulations which are easily to be confused in Matlab. If with dot, it's element-wise, right? If it's dot, it's element-wise. If it's no dot, it's matrix product. For matrix product, you need to make sure that the dimension matches. For element-wise manipulation, the 2 matrices need to have exactly the same dimension. Therefore, they can have the element-wise product. Right, so this is very tricky point that will be confused. Right, so if you have this dot matrix, dot multiplication, you will have the element-wise product, which is the first times first, which is 6, second times the second, which is 10. Right, so you can try in your command window to see whether that works. The matrix product is, I would say, the mostly used operation in Matlab. But please make sure that you know which manipulation you did and the dimension of matrix agrees. Now you can go to example 4. And then you can try this code, run it, and see whether it gives you correct answer. And if it's not, trying to fix it. Oh, sorry. Right, if you have this manipulation, these are 1 times, I don't know, 1 times 8, probably 1 times 8 vector. There's another 1 times 8. What do you give to me? You say that the dimension of matrix does not match, right? Because it's 1 times 8 multiplied by 1 times 8 matrix. So matrix product does not work. So instead, you need to have element-wise manipulation. And now it gives you answer, which is scaled values. Scaled values means that the raw values was scaled by these scaling factors element-wise. Right, so then you get everything. The product is conducted 1 by 1. Okay, so let's back. And the next thing is, again, the matrix, because it's a bit tricky part. We can also combine these two matrices. And one way is to use a function called cat. If you cat them from their row, you just type cat1 and these two matrices or two vectors. And then these two vectors will be aligned by the row. And if you cat2, they will be aligned by their column. The same thing you can do simply by using the comma. Right? Comma, remember, comma is not to switch the rows. So therefore, keeping the same row and aligned in column. So therefore, you see these two matrices, two vectors are aligned in this way. If you have semicolon here, then they will switch the row and be aligned in other rows. So these two ways are used to concentrate the matrix, to combine the matrix. And so the same thing as go for, we combine the matrix. If you have 2 times 3 matrix, you can combine the same way with the vectors or matrices. So now that after you combine this matrix, could you use the size function to check the size of the concentrated matrices? Right, so you do this combine, for example, do this and this. Let's say you have done this to combine these two vectors. Could you use the size function to check their size to see whether that makes sense? If you have these two these two vectors combined, you type length. So length function will only give you the length of these columns. So it only has 4. So size function will give you size of this matrix. But then the question is, if you do this, why do you have the size to be 1 and 1? Any quick answer? Right, I see some answers in the chat. The reason is that here we do not have semicolon here. So after we have that, the ins variables will be covered by this 4, right? So previous ans was this matrix, but after this step, ans will be covered to be 4. Right? Then this ans is only a number, which is a 1 times 1 matrix. So if you check the size of the arranged matrix, it will be 2 times 4. And sometimes I also want to find elements in the matrix, right? So if I have a matrix here, I want to find where is the element equal to 1, right? So I will type find, then this matrix equal. So double equal means to judge, to make a criteria whether it's 1 or not, to check whether it's 1 or not. If it's 1 equal, it's just give the value to the variable. But if double equal, it is to check whether this variable equal to this value. So find this matrix equal to 1 is to find where the element is equal to 1. Right. So it will go from the first column, second, third, and to find 1, 2, 3, the third element to be 1, which is 3. So this way you can find in a big matrix where is some value you want to have. So if you do not specify which value you want to check, you just type find ans. It will automatically find those non-zero elements. Those non-zero elements, which are 2, 3, up to 8, except the first one. So this is a default of this function. I saw a question in the chat room. When we define matrix, can we use those things without the comma? Yes, we can. So if you type space without comma, it is equivalent. So we have previous here to define these matrices as this way, right? Comma to separate the element, but keep in the same row. Semicolon, switch rows. But alternatively, you can also have the space, which is equivalent to have a comma here. Right. I didn't introduce this before because it's we already have a lot of alternatives to define the vectors, right? So that's why you say since you have many different ways to do that, it is easily get confused. So make sure you use those ways of defining matrix correctly. And last thing we want to introduce for this part is we have a function called fprintf. This function is a little bit complex than display we introduced before, because it can display both some strings and variables at the same time. For example, if you type day 1 equal to 1, a day equal to 1 program, you have the code, single code, Matlab. This will specify it is a string. Once you have single code, then inside is a string. And you type fprintf. Today is this percentage file D of percentage file S, and then you give this to argument. So the usage of this fprintf is you can it will replace this percentage thing as the variables constitutive one by one. So the first percentage will be replaced by this variable day, which is 1. And the second percentage will be replaced by this variable program, which is a string. And when you print this, you need to specify what is the type of this variables you want. The first one is a digit. So it's percentage D, which is an integer. And if it's percentage S, it's a format string. So it's a format string. You can try this, it will give you this output, right? So fprintf is a bit complex, a bit complex than the display, because it can display a composition of different types of variables. Here, day is a numerical value, program is a string. But by having them, we can output a very complex sentence. And you can also insert the /n, which will switch the role of the print. /t will have a type. Right? So those guys will, some of them will be used later when we want to print out some result. So now could you open the example 5? Could you follow the comment here to achieve this tasks one by one? Right, this get a little bit complex, and take a few minutes to try that. Combine what we have learned. So let's see this together. So first you want to combine these two matrices. Remember, you want to combine, if you want to combine them into a single row, just use a comma here. And if you want to multiply element-wise, dot multiply. Right. So the last thing is to print out this result. Let's say if you combine these two matrices, it will give you a 1 times 8 vector, right? And then this 1 times 8 vector will be multiplied by the row values. You will get scaled values. And then the final task is to print out the 7th value of row value, scale value, and scaled value. Right? So this sentence has been inserted here, which is the 7th entry of scaling value, scale value, right? So, and remember here, we have the percentage file D, means we need to insert a number, a digital number here, where we will insert the row value, and the 7th is to have a small bracket 7. So when you have a vector, let's run this first. When you have a vector row, right? So row is a 1 times 8 vector. you want to extract it element, like the 7th element, it's just a small bracket 7, right? It's not middle bracket or big bracket, it's small bracket 7. And then it will give you the 7th element. And you can also do this for first element, second, it's not middle bracket. What do I have in you? So it's not middle bracket. So it's small bracket, and we want to take out the 7th element for the row value, for the scaling value, for the scaled values. And here just insert correspondingly %d. So the first %d will be replaced by this one, the second by the scaling, and the third by scaled. I'm sorry, I didn't do it by myself here because time is a bit limited now. But I guess given this task, what you need to insert here is just to add the %d, right? %d, and then it will be replaced by those values. And here is a solution if you haven't got that. So it will print out this sentence. Here we have /n, it will change the row, switch the row. And row value, then this guy will be replaced by the 7th element, which is 5. We have 5. And we have scaling value and scaled values. So you can print out everything you got by use fprintf. It's just that you have to take a bit more time to write out this sentence and insert these values correspondingly to where you want to put them. Okay, let's continue to the last part of today. And we have previously introduced a bit more about the format of the data. And since now we have also introduced matrix. Right? So just here want to briefly review the data types. We have variables. You can check its type by type the class, my variable. It gives what is the data type. If it's a value, it's a double value. Double value means it's a type of numerical values you have with certain precision. And if you have a string, then the class will give you it's a char, so it's a character. So all these different types of data can be checked if you want. So we have many different types of data, right? Like the numerical value, the char, which is also string. And later we will get more complex thing called cell. We'll get there when we introduce them. And structure will not be mentioned in this class, but it's also commonly used. And functions. So function handles it's a different thing from function, but which will also not mentioned in this class. These are a bit more advanced data types, but just to introduce that there are different data types. And this is another example to show these data types. We have those variables. We check whether it's a char, and we can print it out and check whether it's an integer, right? So for example, this one, if we check whether it's an integer, the answer is 0 because it's has many digits afterwards. Right? And we can also check whether after we put a unit 33 is to make it to be an integer. Right? It's like a round function, just to drop the digits after the integer and then keep it as an integer. And then you check whether it's an integer, it is. So just a quick mention to how we can check the data types. You can open the example 7 to have a practice on this. So this one is only for certain users. It's not very commonly used, but it's just to give you a sense that you can check the type of data. You can run this code first and see the result. The task here is to make x to be an integer. So if you haven't done that, so this problem actually is a bit confused. So X is a matrix, right? So if you check whether it's an integer, it is not. It's a matrix, and whether it's float number, it is, and whether it's a vector, it is, and whether it's a scanner, it's not, right? So the way to make an integer is probably you have to take the element to be an integer. Right, you can take the unit 33 to try that and to say whether that's an integer. Okay, so the only thing about those previous introduction is just to make sense that there are different data types. The more important thing is we want to do certain operations on these data. And to do that, we have introduced the arithmetic operations, both for values and vectors and matrix, right? So another type of operations is called rational operations. If we have the double equal here, it will check whether it's equal to the value, right? So same thing to have the less or greater. And to check whether it's not equal, it's this slash, this tilde, and we have the tilde equal to check whether it's not equal. And those rational operations are useful for the if else statement we will introduce right now. So if statement is like sentences to say if a condition matches, we will go into certain code. If does not match, we will just pass this part of code. For example, here I have number 1 equal to 0.5. Number 2 have this rand function at 1, which is just a random number from 0 to 1. So each time it will generate random number, and it will have half chance to be smaller than 0.5, half chance to be greater than 0.5, because it's a uniformly distributed random number from 0 to 1. So then you have this if statement, and if the number 1 is greater than number 2, you will display number 1 is bigger and let the maximum to be number 1. And then you run this script, you see that sometimes you just run this script. This script is called if, right? Run this script, you don't see any result. Right? But some other times you see the result. The reason is that for these previous runs, the random number happens to be greater than 0.5, greater or equal than 0.5. Then this condition does not match. It will pass this code, give you nothing. But if this condition matches, you will get into this code and give the output max to be 0.5, which is number 1, right? Because number 1 is bigger. And as you can see, to make it a bit more complete, you have another part called else part. That is, when this condition does not match, I will run another part of code. Right? For these cases, it's just have else with a number this condition does not match. I would say number 1 is not bigger, and maximum will equal to number 2. Right? You can then run this script. You say sometimes it's 0.5, which is this case. Sometimes it's greater than 0.5, which is the other case. Right? So by having this if-else statement, you have some condition to run certain code. Then you have even more complex one to have the if statement, else if statement, and else statement. If this condition met, we go here. Then else if this condition does not met, but this condition met, then we will go to this part. And finally, if all the previous does not match, we will go to the third case. Right. So first case is number 1 is bigger. Second is number 2 is bigger. Third case is that they're equal. So now we will have a complete code to compare two numbers. Now, could you open the example 11 to try this if statement out? So the task is that just delete slightly or march, right? If it's greater, the difference is greater than 50, I would say it's much bigger. If it's not, it's slightly bigger. So this is very simple. You just simply need to delete this guy. It's much bigger when the difference is greater than 50. If it's not, then it's slightly bigger, right? So you say this if statement, if this condition met, we say it's much bigger. Else, we say it's slightly bigger. And if it's not the bigger, then we will have they are equal, right? So if they are equal, we will say they are equal. Then the remaining case is the first number is smaller. So you can run this code. You say, okay, so for these two numbers, as an example, we will get the first number is bigger. And since their difference is less than 50, it's slightly bigger. Right? So it actually gets into this part of code and this part. The other part of the code doesn't have any function, was not go over because the condition was not met. So this is the usage of if statement. It helps you to run certain part of the code when the condition met. So any question about if statement? Okay, so if not, we still have a few minutes. Let's quickly introduce for loops. For loops is similar as if. It's a different sentence, but it's just runs the certain values, go over certain values. Let's say you want to have a repeated sentence to go over something, and then for loop is one choice. For loop, for example, here, if I want to print out the value from 10 to 20, right, I have 4 A, which is a value from 10 to 20. I remember the default length of here is 1. So it's 10, 11, up to 20. And every time, so it will go through these sentences inside repeatedly. The first time is 10. So value of A, remember here, since we have the percentage %d, then you replace to be A. Then /n is to switch the row. So every time you will print value of A and print the A value, which first time is 10, and then 11 and 20. Right, by having this for loop, we can repeat it doing something. So now could you adjust to print from 0 to 15? Adjust this for loop to print from 0 to 15. Any problem? Okay, if not, I can simply do this by like from 0 to 15. So then it will print out 0 to 15. So this is the answer, but it's just to help you remember that when you have for loop, it is a digital value from certain range you specified. And the default of this comma is 1. So it's from 0 to 15 with step length 1. Okay, then we finally get into the homework of today. It is a little bit challenging, but please try that. So the homework is, we have a set of genes where they have a name, right? Have I1, BCL. This is a set of genes. For those you do not have biological background, just remember it's like ABCD. It's the name of genes. And one thing we haven't introduced is that this data type is actually a cell. So we will introduce this tomorrow. But for homework, I still want you to try that. So this hint is that if you want to call the ith element of this cell, you need to use big bracket rather than small bracket. And for this gene, they have different values, expression values. Right? So this is a vector. And when you want to call the ith element, you just need to use small bracket. So only thing you need to, we haven't told is that this cell variables have the ith element, which need to use the big bracket to extract. And we have give you the threshold value 20. Now the task for you is you write a for loop to go over this gene list to check it one by one. And if the gene expression is over than this threshold, here you need to use if statement. If this gene expression is over than this threshold 20, you print the gene ith entry of this list, right? Gene ith entry of this list has the expression, has its own corresponding expression. Right? For example, I go over the list, I check the first gene, IL1A, the expression is 4, does not over threshold. So it will not print out anything. Then I go to the second gene, NF-kappa BI, NF-KBIA, which is 56, if the expression is over than 20, then it will print the gene 2's entry in this list. And this AF kappa BIA has the expression 56. Right. Go over this gene list one by one to check whether the expression over the threshold and print them out. So what you will need to use is a for loop, we have just told, and the if statement, and then the fprintf. Fprintf, you can refer to the previous examples of how do we use that. So if any question about this homework? Please try that. I guess that's a really good test to say whether you have really mastered how to code we told today. And please forgive some briefness for these online lectures. And nothing that is in this chat room is for uploading this lecture. I think I have sent you this lecture slide and the code in the email. You can check this lecture, this slide, and this code in order to accomplish this homework. And for the final quiz, some of you ask, final quiz will be sent to you later as a link, and then we will do it together in the last course. So with that, that's all for today. If you have any question, you can stay here and ask me any questions. That's all. See you tomorrow.